So good afternoon. Perhaps magbibigay tayo ng konting introduction to fluid dynamics. So kung paano ba siya sinasimulate. So everything begins with establishing the governing equation. So yun naman yung mahalaga. Pag nagna-navigate through ka sa mga research, of course you get overwhelmed sa plethora ng papers na pwede mong pasahin to learn about that. But it's best to learn back to the basics. So, on how to appreciate these kinds of things. So, balik muna tayo sa laws of motion. So, Newton's laws of motion. Ano ba yung unang law of motion? So, body stays at rest or in constant motion unless you apply an external force to it. Second law naman states that yung whatever change dun sa acceleration sa velocity, which pertains to acceleration, is mainly proportional to the external force that was applied to it. So yun yung mainly natin gagamitin for that Newton's third law. So yung an action has a equal and opposite reaction. So kung may force kang naka-apply, meron kang opposite na reaction. So if I'm pressing this board here, meron yung board din at the same time is acting a force that is equal dun sa force na in-exert ko over it. So ginagamit yun to identify ano ba yung internal forces and ano ba yung external forces. So yung internal force is a reaction to the external force that was applied to it. So, yung internal force could be yung internal stresses na nagkakos ng deformation dun sa material. Pero, syempre, ang focus natin is continuum mechanics. So, I rather fluid dynamics. So, to explain briefly, so yung Newton's second law. So, sum of all forces basically is basically equal to mass times acceleration. So mukha siyang simple, pero if you were to deal with some of the mathematics and kung paano siya i-convert, so basically kailangan mo identify lahat ng forces. Tapos kailangan mo identify yung mass, yung subsequent acceleration niya. So, for fluid dynamics, hindi siya ganun ka-straightforward. So, yung sum of all forces can be expressed in terms of continuum mechanics by the del operator dot the Cauchy stress tensor plus actually yung other external force na pwede mong i-apply. Rather, ganyan na lang. This is a tensor, so kailangan naka-highlight in bold, equal basically to mass times acceleration. Yung acceleration is another vector. So naka-bold ito. So to express in terms of initial notation, so basically you have ij that I plus plus f of I is equal to MAI. So yan, ito yung initial notation for Newton's second law. So paano ba natin i-interpret yung initial notation? So if we're to speak about IJJ, yeah, para IJJ nga siya. So, kailangan lang natin i-identify. Sorry. Wait lang. Hindi, JJ. So, initial notations, bakit ako nalilito sa pagsa-setup nito? Kasi, kung paano mo siya i-expand. So, pag this one here is what's called a second order na tensor. So yung parang zeroth order na tensor is basically scalar value. So any value na, so mag-multiply ka ng scalar dito, it's in the zeroth order. First order is what you are familiar with, what's called vectors. Then second order, itong part na to. So kung zeroth order, so any constant A. Pag first order, pwede natin i-treat as EI. Then pag second order, sigma ij. Then pag third order, fourth order. So a sample of third order na tensor is yung elasticity tensor, which is Cijk. Then another third order is yung permutation symbol Eijk. Pero syempre may mga special values yan. So pagdating sa continuum mechanics, so muna tayo, deal with muna tayo with continuum mechanics. How do we define this? So pag sa initial notations, initial notations muna. So pag sinabi mo sa initial notations, kailangan mo ma-identify alin ba yung dummy saka yung dummy index, tapos alin ba yung real na index dun sa equation mo. Pag sinabi mong dummy na index, meaning pag sa isang notation, so meron kang A, I, for example. So since nag-recur yung initial notation mo dun sa equation, so this will be a dummy index. So this can be interpreted, for example, meron kang I is equal to 1, 2, 3. So dito, meron kang I, A11 plus A22 plus A33. Kung halimbawa naman na Aij, so alin dito yung dummy index? Yung I pa rin still, pero yung J is hindi siya dummy index. So this actually expands to 3 notations. So meron ka kasing I and J is equal to 1, 2, 3. So meron kang J equals 1. So J equals 1 here. So meron kang A11 1 plus A221 plus A331 plus J equals 2, A112 plus A222 plus A332, then J equals 3, A113, A223 plus A333. So, ganyan siya nag-expand. So, anong mga implications nito? Balikan natin to. Alin dito yung dummy na index, tapos alin dito yung hindi. So, yung dummy na index is definitely J. So, pag sinabi ko naman pala na, halimbawa, sige, 4 na tayo sa conservation of mass. So it's basically states na mass is neither created nor destroyed sa isang system. So meron kang isang property, halimbawa meron kang isang system dito. Tapos whatever property that you're introducing into it is neither created unless meron kang tinatawag na source, tapos meron kang tinatawag na sink. So yung sink reduces yung value, overall na value ng property within dun sa system mo. Yung source introduces new value. Pero kung tanggalin mo itong dalawa, itong nandito lang, so whatever value na meron dito is naka-conserve. So whether particles yan, whether sabi nga mass, whether volume ng water, or in this case velocity, or pwede rin velocity. So what flow, given na incompressible yung fluid, so walang pagbabago dun sa density niya, whatever flows in is equal to whatever flows out. So, para ma-identify, so meron kang flow going in. So, treat muna natin as U as yung velocity. Pero, halimbawa, yung the flow that goes out, so whatever changes that happening in here. So if you treat this as dx, so yung size ng finite volume mo na sinet. So change ng velocity over dun sa over dun sa sa length na travel niya. So meron kang du plus dx. And remember na kapag continuity equation, so whatever goes in should be equal to whatever goes out. So dapat ito ay equal. And therefore, cancel. Dapat yung du over dx equals to 0. And kung i-convert natin into 3D, dui, dxi ay dapat equal sa 0. So, this one here can be interpreted as ui, i. So, meaning, yung i dito is yung parang kinukuha mo yung derivative niya. So, na-mention ko na yung conservation of mass, mababalikan natin to. So, this one is the continuity equation na ikakapol mo sa conservation of momentum. So, yung second law is basically conservation of momentum. So, itong sigma ij is what's called yung Cauchy stress tensor. So it's mainly divided into two terms. Yung first term is yung Lame's constant for bulk viscosity. So yung bulk viscosity affects what's called yung volumetric strain. Mainly affects. Tapos, yung molecular or kinematic viscosity, so this one is viscous strain, mainly deviatoric siya. Anong kaibahan ng dalawa? So, kapag sinabi mo na volumetric na strain, or ibig sabihin, from the initial state, nagbago yung overall volume niya. So, nag-shrink siya, halimbawa, to its side, ibig sabihin, meron kang volumetric strain na negative na along this axis here. Yun yung sinasabi lang niya. Pag sinabi mo na deviatoric strain, so, this one here, so if you treat this as x, so, yung volumetric strain, so, yung pagbabago nito, itong dimension na to with respect to x, yun yung tinatawag na finite na strain. So meron kang EII would be simply kung ano man yung naging displacement nito from here to there, tapos from here to there. Oo. So meron kang ngayong so change, whatever change sa display, parang over time. So ano yan may time frame yan. So basically, ano yung naging change niya over time? So kaya velocity yung ni-express. Ui over xi. Think partial to. So ito yung finite strain na tinutukoy nito. So, speaking of finite strain, bago tayo pumunta dun sa pagbuo ng constitutive relation. So, yun yung volumetric. Yung deviatoric naman is kung meron kang square na ganyan. Yung strain actually manifests in this direction here, in this direction here. So, this is shear stresses. Then, ganito din yung manifestation ng shear stresses. It causes ito, nausog ng pagganon, then nag-elongate itong part na to. So, if you retain this one and retain this one, so nag-elongate siya, then ito rin nag-elongate. Nag-elongate. So, ditong part na to, since perspective niya is palayo, so pakiramdam mo, Hindi, walang nangyari. So, hindi nagbago yung volume, nagbago yung shape. Therefore, deviatoric na strain yung tawag sa kanya. So, yung generally, EIJ, so no matter what axis, is the average ng dalawa. So, one half DUI over DXI plus DUJ, tapos, DXJ to, tapos, this one here is J, tapos this one here is I. So, yan yung, so walang dami na, walang repeating na value dun sa isang term. So, medyo safe naman siya. So, unless, syempre, pag yung J is equal to I, so magre-repeat tong dalawa. So, magiging katulad lang ng kanina. So, yun yung kaiba ng dalawa. So, sa pag-build up so, meron kang Lane's constant for the volume, volumetric na viscosity na nag-act. Tapos, meron kang EKK. So, kasi, remember, halimbawa yung goma, kapag pinul mo siya, ang nangyayari is, okay, mahaba nga yung length, pero nagna-narrow down naman yung other dimensions niya. Yung thickness niya, nagna-narrow down. So, it has to be in relationship dun sa parang sum ng lahat ng strain. So, pwede mo sabihin na E11 plus E22 plus E33. Ito yun yung K. So, lahat ng sum ng volumetric strain, right there. Tapos, kaiba na, meron tayong tinatawag na special na constant called the Kronecker delta. So, ang Kronecker delta, dalawa lang yung values niya. So, either 1 or 0. 1 siya kapag I equals J. 0 siya kapag I is not equal to J. Ilan naman si Kronecker delta. Another special na value na kailangan natin i-consider is yung permutation na symbol. So, yung permutation symbol IJK, kapag so, ganito mo siya titignan, IJ to K, kapag ganito yung rotation niya, positive 1. Kapag baliktad yung rotation niya, so isa sa main prerequisite is I should not be equal to J, so I should not be equal to J, should not be equal to K. Otherwise, kapag na-violate ito, 0 siya. Pero kung hindi na-violate yung so i-note mo yung rotation. So kung ganito yung rotation, so yung I ay yung J, kung ganito yung pagkakaayos niya, positive. Kung other, so alam mo, IJK, JKI, KIJ, so positive. Pero kung baliktad yung rotation niya, IKJ, KJI, JIK, negative siya. So yun yung permutation symbol. Pero this one here is yung so na-mention pa lang natin yung volumetric na component. Tapos meron kang 2 tau EIJ. So paano mo siya i-interpret? So paano ba siya i-interpret? Una ay So, you treat this as pag sa fluid dynamics, since mainly ang main assumption mo kapag as laid down by Newton when treating Newtonian fluid is yung strain is linear and somehow hindi nagmamanifest itong Lane's constant. So, walang puro deviatoric lang yung or rather this one here, kung nag-manifest siya, would be haba nito So kung I siya, so yung mga principal mga volumetric na stress, this one is simply 1/3 ng tinatawag na mechanical pressure. So yun yung main assumption dito. Tapos this one here is linear in nature. So basically, yung Cauchy stress tensor mo, ang matitira is equal to 1/3 -1/3 mechanical pressure, since lahat ay papunta sa gitna. Kaya negative siya. Hindi siya yung expansive. 1/3p, 1/3p, -1/3p. This one here, pwede natin na tau. So, isa-substitute na agad. So, tau 1, 2, tau 1, 3, tau 2, 1, tau 2, 3, tau 3, 2, tau 3, 1. So, basically, pwede mo rin sabihin na si ij would be simply equal to 1/3p tapos identity matrix plus -1/3p plus yung deviatoric na component. So, sigma ij. Okay. Ay yung tau ij pala. So, this one here, wait lang. Okay. If you were then to substitute, so yung tau ij is basically equal to this one here. Pero na-mention na natin na yung finite strain is 1/2 that one here. Pero sige, shenanigans aside, substitute mo lang siya dito. So this one here becomes 2, magiging na lang, mu multiplied by this value. Ngayon, isa-substitute mo siya dito. So, kailangan i-differentiate mo siya. So, kapag dinifferentiate mo siya, halimbawa, kunin lang natin, I equals 1 para mas mabilis ma-visualize. So, kapag visualize, pag sinolve natin to, so yung Cauchy stress tensor ay kinuha natin yung derivative with respect to with respect to J, so yung changing na values. So, alam natin na basically, wait, naghiwalay. Okay. So, matitira dito sa sigma ij mo is x1. Maka-cancel wala actually yung ibang value. So, dapat 1, 1 lang. 1, 1, 1, 1 plus 1, 2 plus 1, 3. So, negative 2p over x1 plus yung unang value is pag in-integrate, pag dinifferentiate mo to, so yung unang value i-set ko na nga ng 1 to. So meron kang 2u1 x1 plus 2u2 over x2 plus 2u3 x3 plus, I think this is minus pala, plus mu, then second order mu1 x1 mu1 x2 u3 and then u1 x3. This one here, remember yung continuity equation. So ito I xi, so basically u1 over x1 plus u2 x2 u3 x3 is equal to 0. So this one cancels out. So yung natira among the forces mo is this one here, so pressure gradient, and this one here which defines yung shear stress. Shear stress gradient actually yung tamang term. So, na-identify mo na yung part na to. So, kung magdadagdag ka ng Fi, pwede yung gravity. So, acceleration due to gravity. So, 1 over gravity. So, rho g. Tapos negative. So, ayan, meron kang, kung y pala. So, rho gi. So, remember na kung vertical, rather. So, 0, negative 9.80. Kasi yung y lang yung may value. So, this one is G1, G2, G3. So, walang value yung G1, so cancel lang. Pero kung along y, meron na siya. So, na-identify mo ng lahat ng mga forces. Then, last siguro, usog na lang natin to dito. And palitan natin ito. Litan natin. Since dami na constant siya, pwede kong ilagay na JJ. Tapos itong 1 represents yung I equals 1. So, ito ay magiging I. Ito ay xj. Then, meron kang rho over tx I. So, meron ka ng sum of all forces. Itong part na to, nasa-resolve mo na. Problem na lang is yung acceleration. Yung acceleration, pwede mong i-treat as rho ulit. Rho du I over dt. So, bakit capital letter? Kasi yung capital letter na yan is what's called material time derivative. Bakit may gantong uri ng case? Recall na kung nasa perspective ka ng object, so ikaw ay naglalakbay across space. Kung nag-accelerate ka, that's from your reference frame. So kung nag-accelerate ka rito, so meron kang acceleration niya. So kung ikaw din mismo yung observer, ito lang yung ma-observe mo. Pero kapag if you are observing acceleration na yun from a certain point in space, so in a fixed reference point, so this one here also travels at a velocity v. So meron ka ng dalawang components. So change in velocity with parang sa perspective niya, tapos kung gusto mo i-convert dito, may madadagdag ka pa na acceleration across space. Kasi ito, nagbago siya ng position after some time t here. So, meron kang acceleration over time. Tapos meron ka rin acceleration over space. So kung ano ba meaning ng acceleration? Yung change in velocity across space. So kung nandito ka, ano yung velocity? Tapos after some time, pagdating mo dito, ano yung naging velocity? Yun yung acceleration over space. Tapos with respect sa sa observer, yung acceleration na naranasan niya, kung ano yung naging change ng velocity based sa perspective niya, yun yung acceleration over time. So yung addition ng dalawang to, yun yung material time derivative. And pwede pa natin itong na this one is Eulerian acceleration. This one here is convection. Or advection actually. Advection. Kasi velocity. Kasi vector yung tinatransport mo. Pero kung scalar siya, convection yung tawag. So, paano mo ngayon masabing acceleration over space? So, yung material time derivative actually is partial over t plus may nakaabang dun sa whatever constant na ilagay mo. So, whatever, halimbawa, vector, u. So, magiging dui over t, tapos dui, tapos naka-dot product siya sa Kronecker delta. So, meaning ito ay divergence. So, pag sinabi mong divergence, divergence nga ba? Okay, sige. Divergence. Yung component ng velocity na yun, so pwede mo siya ma-interpret as, ui. Hindi. Meron na palang, since acceleration across space, so space after some time, yung distance over time, so meron kang delta x dito, tapos this happen over a certain period of time, so meron kang velocity. So meron kang ui, tapos naka-abang. So yun pala yun. So kapag uj, I think, oo. So mangyari dito, so yung dui over dt mo will be equal to partial of ui over d plus yung acceleration over space. So meron kang u1 or uj tapos partial ng I over xj. So ito yung material time derivative. And i-multiply mo lang sa rho, so substitute mo lang dito. So meron kang, or rather, yung rho na yun, i-divide mo na lang dito. So 1 over rho. As this one is over rho here, over rho there. So meron kang dui dt plus uj dui xj. So ito na actually yung Navier-Stokes equation. So ang haba ng naging derivation. Pero ewan ko kung naintindihan. So nagsimula tayo sa Newton's second law. So yung sum of all forces, ito yung forces na yun, ito yung internal force, ito yung external force, would be equal to mass times acceleration. So since negligible for air, so yung gravity hindi naman natin kino-consider. So mainly ito lang. So we need to define yung acceleration, we need to define yung internal forces na nag-cause. So yung internal forces is mainly defined by the Cauchy stress tensor. So ito siya. And para mapadali lahat, sineparate into its volumetric, nakakapekto sa volume, and yung deviatoric, nakakapekto sa shape na components. And sa deviatoric na component, syempre mainly, since linear yung relationship ng shear strain dun sa shear stresses, which is one of the definitions ni Newtonian fluid, pwede mo ngayon na makuha agad direkta yung finite state. So, ay parang relationship nung basically displacements over time or yung strain basically. So, meron ka ng value dito. Then, kapag kinuha mo pa yung derivative with respect to J, yung expansion kanina, ang matitira is itong part na to, which represents yung shear stresses. And yung mu over P is actually nu. So, which is yung kinematic viscosity. So, synopsis mo lang to, kinuha mo yung volumetric na stress would resulted into pressure gradient. So, kinuha mo kasi yung gradient. This one here is yung shear stress gradient. So, kaya naging ganyan siya. And eventually, yung material time derivative, meron tayong acceleration over space, tapos meron din tayong acceleration over time na component. So, sinubstitute natin siya. So, this one here is yung Navier-Stokes equation.